The Voyager mission remains a profound symbol of human achievement, and a recent event served as a powerful reminder of just how extraordinary its journey has been since its inception. Launched in 1977, NASA's Voyager 1 and Voyager 2 spacecraft set off on an ambitious mission to explore the outer solar system and eventually venture into interstellar space. These identical probes were equipped with cutting-edge instruments of their time, designed to reveal the secrets of distant planets and extend humanity's reach beyond anything previously imagined. NASA launched two spacecraft in 1977, Voyager 1 and Voyager 2, on a mission unlike any before. Their purpose was to explore the far reaches of our solar system and peer beyond, venturing into realms previously untouched by human hands. Built with cutting-edge instruments for their time, these twin pioneers were not only scientific marvels but also symbolic emissaries of humanity. Equipped with the iconic Golden Record, a time capsule containing the sounds, music, images, and greetings of Earth, they were designed to extend our reach into the cosmos and perhaps one day communicate with intelligent life far beyond our understanding. For more than 4 decades, the Voyager spacecraft have been transmitting invaluable data, reshaping our understanding of the universe and showing us how even the smallest human creations can leave an indelible mark on the vastness of space. Voyager 2 began its journey with an extraordinary encounter with Jupiter, capturing detailed images of the planet's turbulent storms and swirling cloud bands. It then moved on to Saturn, revealing the planet's intricate and dynamic rings with greater clarity than ever before. Unlike the static bands once believed to encircle the planet, the rings proved to be complex systems featuring kinks, braids, and rapidly moving particles, details that reshaped planetary science. Voyager 2's trajectory allowed it to go even further than its sister spacecraft, reaching Uranus in 1986. There, it unveiled a world unlike any other, an ice giant with a unique rotational axis tilted at an almost impossible 98 degrees. This alien world offered up 2 new rings and 11 previously unknown moons, each of which presented scientists with tantalizing mysteries about the planet's formation and evolution. It also recorded shockingly frigid temperatures of -353 degrees Fahrenheit and passed through a plasmoid, giving us a rare glimpse into Uranus's twisted magnetic field. By 1989, Voyager 2 had reached Neptune, completing its grand planetary tour. This final stop was among its most memorable. The deep blue hue of Neptune's atmosphere, fast-moving storms, and the fastest winds in the solar system, clocking speeds of over 1,200 miles per hour, were captured in stunning detail. The spacecraft also studied Neptune's largest moon, Triton, revealing geysers of nitrogen ice erupting into space and a mysterious crust that hinted at a possible subsurface ocean. Triton's strange and dynamic surface suggested that even in the coldest, most remote corners of our solar system, there might be the ingredients necessary for life. The discovery of Neptune's highly tilted and offset magnetic field also challenged previously accepted models, offering new insights into planetary magnetism. Though the Voyagers were originally built for 5-year missions, they continued to operate well beyond their intended lifespans. Their endurance is a testament to the brilliance and foresight of the engineers who built them. Even as their power supplies dwindled, each now operating on less energy than a typical household light bulb, both spacecraft continued to beam back data. In fact, it wasn't until 2012 that Voyager 1 crossed into interstellar space, breaking through the heliosphere, the protective bubble generated by the Sun. Voyager 2 followed in 2018, entering the interstellar medium and giving us our first direct glimpse into the space between stars. And even now, in the darkness of deep space, Voyager 2's instruments have picked up a faint eerie hum, the sound of plasma waves in the interstellar void. These signals provided the first continuous measurement of plasma density in this uncharted region, a crucial piece in understanding the universe's structure. This journey into interstellar space hasn't been without its difficulties. The signals sent by Voyager 2 now take over 18 hours to reach Earth, and communication requires an incredible degree of precision and ingenuity. Recently, a misstep highlighted just how fragile this connection can be. NASA engineers accidentally sent the wrong command to Voyager 2, causing a temporary loss of contact for nearly 10 days. At a distance of nearly 20 billion kilometers from Earth, the spacecraft was essentially on its own. Fortunately, the problem was resolved and communication was restored, underscoring the remarkable persistence and skill of the mission team. Each message received from the spacecraft is not just a scientific triumph but a celebration of human perseverance in the face of overwhelming odds. Despite these challenges, Voyager 2 has continued to provide groundbreaking insights. Its data has played a crucial role in the development of modern astronomy, influencing the design and focus of future space missions and telescopes. The mission has also inspired increased interest in studying icy moons with subsurface oceans, such as Europa and Enceladus, which may harbor the conditions necessary for life. The legacy of Voyager 2 is not limited to the outer planets. It has sparked a broader interest in exoplanets, helping scientists refine their search for Earth-like worlds beyond our solar system. The knowledge it has returned has paved the way for a new generation of exploration, one that looks beyond our sun to the distant stars. One of Voyager's most iconic contributions to human understanding didn't come from a planetary encounter but from a glance backward. In 1990, Voyager 1 turned its camera back toward Earth and captured the pale blue image, a photo that showed our planet as a tiny speck, just 0.12 pixels in size, suspended in a sunbeam across the void. This haunting image, taken from more than 4 billion miles away, became a defining symbol of our place in the cosmos. The late astronomer Carl Sagan eloquently reflected on the image, emphasizing the fragility of life on Earth and our shared responsibility to protect it. His poetic meditation on the pale blue resonated with millions, reinforcing the profound philosophical implications of space exploration. As Voyager 2 continues to journey farther into the unknown, its scientific payload becomes increasingly limited. Engineers have had to shut down non-essential systems to conserve power, making difficult choices about which instruments to prioritize. Despite its reduced capabilities, the spacecraft still returns invaluable data, whispering faint signals across billions of kilometers of space. These final transmissions are like echoes from a fading but still vibrant voice, evidence that even as its light dims, Voyager 2 remains a beacon of human achievement. Its instruments continue to detect and study the interstellar medium, a region that until recently was only the stuff of theory and imagination. The data has revealed that space beyond the heliosphere is not empty, but filled with complex interactions, electromagnetic waves, and particles that challenge our understanding of what exists between the stars. Beyond the numbers and scientific findings, Voyager 2 serves as a cultural artifact. The golden record it carries remains one of humanity's most hopeful gestures, a message of peace and unity created in the spirit of cosmic brotherhood. The record contains greetings in 55 languages, the sound of a mother's heartbeat, a baby crying, waves crashing on the shore, and music from various cultures and time periods. It represents not just who we are, but who we aspire to be, a species capable of reaching beyond its cradle and offering a hand to the unknown. The fact that this record continues to drift silently through space speaks to the timeless nature of human curiosity and the desire to connect, even across the unimaginable void. The images returned by Voyager 2 during its planetary flybys remain among the most stunning visuals ever captured. Neptune's deep azure hue, Uranus's ghostly glow, Saturn's delicate rings, and Jupiter's colossal storms all tell stories of alien worlds both majestic and terrifying. But perhaps even more powerful are the final glimpses of the solar system's edge and the distant shimmer of stars in the background. These snapshots, captured by a spacecraft so far removed from Earth, remind us of the scale of the universe and the tiny, fragile place we occupy within it. As the mission enters its twilight years, Voyager 2's continuing operation is both a marvel and a mystery. Each year that it remains functional defies expectations and adds another chapter to its already legendary story. It is the furthest traveled human-made object still sending data to Earth. And with each faint transmission, it furthers our understanding not just of space but of ourselves. Its presence in interstellar space is a poetic affirmation of humanity's boundless desire to explore, to understand, and to leave a trace of our existence in the cosmos. Voyager 2 is more than a machine. It is a symbol of resilience, of wonder, and of our shared human spirit. In the end, Voyager 2's journey is not merely a story of space exploration but a chronicle of human endeavor. It exemplifies what we can achieve when we look beyond our immediate needs and dare to reach for the stars. It reminds us that exploration is not a luxury but a fundamental part of what it means to be human. While Voyager may one day fall silent, its mission will continue to echo through time, a quiet but powerful testament to our pursuit of knowledge and our place in the grand narrative of the universe. Its legacy will endure for billions of years, carried by a spacecraft drifting silently through the galaxy, reminding anyone who might one day find it that once, a species on a small blue planet looked to the heavens and chose to explore. As Voyager 2 continues its lonely voyage through the vastness of interstellar space, it functions not only as a scientific instrument but as a symbol of humanity's perseverance and ingenuity. The sheer scale of its journey, now stretching beyond 20 billion kilometers from Earth, invites reflection on how far we have come in a relatively short time. What began as a bold endeavor to survey the outer planets has transformed into one of the most enduring and successful missions in the history of space exploration. In many ways, Voyager 2 represents the best of humanity, our drive to explore, our thirst for knowledge, and our willingness to face the unknown with open eyes and open minds. Its continued operation after more than 45 years in the coldest and most remote environment imaginable is an astounding technical achievement and a stirring human triumph. Every signal received is a tiny miracle, an echo from a machine that defied all odds to speak to us from beyond the sun's protective bubble. The spacecraft's resilience in the face of aging hardware and dwindling power has required NASA's engineering teams to devise clever solutions. As the radioactive decay of its power source slowly saps its energy, the team must continually decide which instruments to deactivate. These difficult decisions are not made lightly. Each component of Voyager 2 plays a role in its ability to sense, communicate, or protect itself. As certain systems go dark, engineers have managed to keep the mission alive by rerouting tasks and innovating within severe constraints. They've extended its operational life well beyond anyone's expectations, maintaining communication through NASA's Deep Space Network, a global system of giant antennas that strain to pick up Voyager's faint, aging signals. Even minor errors, such as the wrong command sent in 2023 that silenced Voyager 2 for 10 tense days, highlight how delicate this dance has become. But the fact that contact was re-established is a testament to the mission's enduring spirit and the brilliance of those guiding it from Earth. What Voyager 2 continues to offer is nothing short of astonishing. Its instruments measure cosmic rays, plasma waves, magnetic fields, and particle densities in interstellar space, data that has never been collected before in such detail. In this environment beyond the heliosphere, where the influence of our Sun gives way to the galaxy's broader forces, Voyager 2 provides humanity's only first-hand experience. The spacecraft's sensors detect the faint hum of interstellar plasma, a persistent tone that varies in pitch and intensity, offering scientists clues about the density and movement of the medium through which it travels. Such information helps researchers understand how solar particles interact with the galactic environment, refining models that predict the behavior of other stellar systems. It's a window into a realm that was, until Voyager, the stuff of speculation and theory, a frontier that lies beyond every telescope's reach, navigated only by these twin relics of human curiosity. The broader impact of Voyager 2 extends far beyond pure science. It has inspired artists, musicians, filmmakers, and writers across generations. The very notion of a tiny spacecraft pushing ever farther into the darkness has become a powerful metaphor for endurance, solitude, and the pursuit of meaning in a vast and often indifferent universe. The golden record on board, with its encoded messages of Earth's diversity and beauty, has taken on mythic significance. Designed by a team led by astronomer Carl Sagan, the record includes natural sounds like thunder and bird song, greetings in dozens of human languages, and music ranging from bop to traditional songs from various cultures. It was never just about communicating with aliens. It was about creating a lasting monument to what it means to be human. The fact that this record now travels through interstellar space, carried by a probe whose systems are failing, makes it all the more poignant. Long after the spacecraft stops transmitting, the golden record will continue its voyage, a silent ambassador drifting through the galaxy, waiting for someone or something to find it. In its earliest days, Voyager 2 reshaped our understanding of the outer planets. Before the mission, much of what we knew about these distant worlds came from ground-based telescopes and educated guesses. Voyager brought us face to face with Jupiter's massive storm systems, its swirling red spot, and its myriad of moons. It introduced us to Io's volcanoes, some of the most active in the solar system, and to Europa, whose smooth, icy surface hinted at an ocean beneath. It showed us Saturn's majestic rings in unprecedented detail and revealed new moons that had never been seen before. Each planetary flyby brought discoveries that challenged previous theories and led to new questions. At Uranus, Voyager found that the planet's magnetic field was unlike anything seen before, tilted and offset in ways that defied expectations. Its blue-green color, featureless from Earth, was revealed to conceal a complex and dynamic system. And at Neptune, the most distant planet visited by any spacecraft, Voyager unveiled the solar system's most intense winds and an unexpectedly vibrant atmosphere, punctuated by massive storm systems like the Great Dark Spot. Even now, the ripple effects of Voyager's observations are felt throughout the scientific community. Missions like Cassini, Juno, and the upcoming Europa Clipper and Dragonfly have all built upon Voyager's foundation. Its findings about magnetic fields, moon geology, and ring systems have informed the designs of newer probes, shaping mission goals and technological development. Moreover, Voyager's passage into interstellar space has laid the groundwork for understanding how future spacecraft might navigate and survive in that environment. In a very real sense, Voyager 2 is the pathfinder for every interstellar mission that may follow, from theoretical fusion-powered probes to the small but ambitious Breakthrough Starshot project that aims to send miniature spacecraft to nearby star systems. As the spacecraft drifts ever farther from Earth, it becomes harder to receive its messages. The faint signals must travel a distance so great that they are weaker than a whisper in a storm. Yet the data they contain is as valuable as any ever received. Each one is a transmission from the edge of the known world, a final message from a frontier explorer. The emotional weight of this journey is difficult to overstate. The spacecraft is alone, traveling through an environment colder and darker than any on Earth, unable to change course or ever return. It is the furthest flung extension of our species, a tiny object made by human hands now sailing among the stars. This poetic reality resonates deeply with those who understand it. Voyager 2's endurance is a reminder that we are capable of extraordinary feats when we combine science, creativity, and vision. As Voyager 2 continues its mission, the scientific world waits with both hope and sadness. Hope because each new bit of data enriches our understanding of the cosmos. Sadness because the day will come when Voyager falls silent, its power source finally exhausted, its instruments forever stilled. There will be no fireworks or final transmission. The signal will simply fade, and the spacecraft will drift on its course unchanged, its voice gone. Yet its silence will not mean failure. On the contrary, it will mark the successful completion of one of humanity's greatest adventures. It will have accomplished what no other object built by humans ever has, journeying farther, lasting longer, and discovering more than anyone dreamed possible when it launched. But even in that silence, Voyager 2's story will not end. It will remain in space, orbiting,